Hello guys, in this video we are going to discuss the solution of the problem, not a subset sum. So let us look at the problem statement. The problem statement says given a sorted array ARR of positive integers, find the smallest positive integer such that it cannot be represented as the sum of elements of any subset of the given array set. So for instance, if this is the array which is given to us, then 7 is the smallest positive integer for which no subset is there with sum 7, because of which we are returning 7. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So to solve this problem, we need to understand two concepts, concept 1 and concept 2. Let us look at concept 1. So concept 1 says if the array is arranged in certain way, and we will discuss about this as well. But for now, let us assume that the array has been arranged in a particular way. And the sum of the elements so far which we have observed is x. Then all positive integer less than or equals to, folks, over here this is less than or equals to x, can be represented by the subset of the array. So let us first understand this. So let us take few examples in order to understand this. So let us say the array which is given to us is this 1, 2 and 3, and let's say we are at this position. So the sum so far is 1, and using concept 1, then all the element less than or equals to 1, we should be able to represent it. So there is just one element which is 1 itself, and we are able to represent it. Now let's proceed forward. Over here the sum is equals to 3. So as per our concept 1, all elements till 3 we should be able to represent it. When we are at this position, the sum is equals to 6. So we should be able to represent all the numbers till 6 using the array. And the way we will be able to achieve this is essentially 1, 2, 3 can be represented as 1, 2, 4 can be represented as 1, 3, 5 as 2 plus 3, and 6 as 1 plus 2 plus 3. And in this way, as you can see, all the numbers till 6 can be represented. Let's take a couple of more examples to solidify our understanding. So let us say the array which is given to us is 1, 2 and 4. In this case, when we are at this position, the sum will be equals to 7. So we should be able to represent all the numbers till 7 using this array. So let us see how we can do that. So 1 can be represented like this, 2 like this, 3 as 1 plus 2, 4 as 4 itself, 5 as 1 plus 4, 6 as 2 plus 4, and 7 as 1 plus 2 plus 4. In this way, all the numbers till 7 can be represented. Let's take one more example and then we will discuss the second concept. So let us say the number which is given to us is 1, 2 and 5. Now when we are at this position, sum is equals to 1 and the number which can be represented is 1 itself. When we are at this position, the sum is equals to 3. So all the numbers till 3 we should be able to represent it. So 1 and 1, 2. Now when we are at this position, the sum is equals to 8. Now as per our concept 1, we should be able to represent all the numbers till 8. But as we can see, 4 is something which we will not be able to represent. So this is an example where the array was not arranged in a particular order, because of which we were not able to represent the number 4. So how do we tackle this scenario? Well, the way we will be able to tackle this scenario is using concept 2, which is the way in which the array should be arranged. So let us discuss concept 2 and that will complete our discussion of solution. So to understand concept 2, what we are going to do is we are going to iterate through the elements of the array and we are going to maintain the smallest positive integer which cannot be represented so far. So let me explain this. So again, let's take some examples. So let us say this is the array which is given to us, and let us maintain the smallest positive integer which cannot be represented so far. So let me just write it down as smallest integer. And to begin with, what we can assume that our array is empty. So this is an empty array. So when the array does not contain any element, then the smallest positive integer which cannot be represented will be 1. Now let us proceed forward. So now we are at this position and the element is 1. Since the smallest positive integer which cannot be represented was 1, and the current element is 1 itself, which simply means now 1 can be represented, because of which the smallest positive integer which cannot be represented now will be given by 2. Let's proceed forward. So now we are at this position. Again, the smallest positive integer so far which cannot be represented is 2, and we are observing 2 again. So the smallest positive integer which cannot be represented will be given by which element? Well, that will be given by 2 plus 2, which is equals to 4. And why is this the case, folks? So recall from our first concept. So we are at this position, and over here the sum is 1 plus 2, which is equals to 3. So that simply means all the elements till 3 we should be able to represent it. So the next element which we cannot represent is 4, and that is why we are putting 4 over here. And the way we were able to achieve to 4 is essentially 2 plus 1, which is equals to 4. And remember, this 1 plus 1 is something which we are already maintaining it over here. So the same effect can be obtained by 2 plus 2 as well. So that is equals to 4. Now let us proceed forward. So the next element is equals to 3. Since the smallest positive integer which cannot be represented is 4 and the next element is 3, that simply means 3 can be represented as 3 is less than or equals to 4, because of which we will be able to represent 3. So the next positive integer or the next smallest positive integer which we cannot represent will be given by 4 plus 3, which is equals to 7. And this is what we are going to return. So folks, this was the case where concept 1 was not violated. Now let us look at the case where concept 1 was violated. So the example which we were looking at was 1, 2 and 5. To begin with, let's say this is my empty array, and in that case the smallest positive integer is 1. The next positive integer which cannot be represented by the array will be 2. Since this 2 is equals to this 2, because of which the next positive integer will be 4. 2 plus 2 is equals to 4. And folks, over here is where the magic happens. So the smallest positive integer which cannot be represented is 4. So this is the smallest positive integer which cannot be represented. And the next element which we are observing is 5. As 5 is greater than 4, then that simply means 4 is the smallest positive integer which cannot be represented at all. Because of which in this case we will not iterate till 5, rather we are going to break from here and we are going to return 4. And that's the whole idea behind concept 2, folks. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find the smallest and an array is given to us. So for this, what we are going to do is we are going to take a smallest positive integer which cannot be represented, which is equals to 1. And that is the case where the array is empty. So in such case, the smallest positive integer which cannot be represented will be given by 1. Now, after this, what we are going to do is we are going to iterate on the elements of the array. So for element in array, and we are going to check if element is less than or equals to answer. So let me explain this part, folks. So over here what we are doing is, so we are at this position and we are checking whether 1 can be represented by the smallest positive integer so far or not. So for this to be represented by the smallest positive integer, this value should be less than or equals to this value. And that is what we are comparing over here. So if element is less than or equals to answer, then in such case, we will find the next element which cannot be represented by the array, and that can be found out by answer plus element. If this condition is not satisfied, then in such case, we have found the smallest positive integer which cannot be represented, and we are going to break from our loop. And towards the end, all we have to do is we just have to return answer. So that's the pseudocode of this problem, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. Over here answer is equals to 1, and then we are iterating on the elements of the array. Element is less than or equals to answer, which simply means the smallest positive integer which is there in the answer can be represented by the elements of the array so far, because of which we are finding the next smallest positive integer which will be given by answer equals to answer plus element. If that condition is violated, then that simply means we have found the smallest positive integer which cannot be represented by array, because of which we are breaking from the loop and we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ solution. So the C++ solution is also the same, folks. Answer equals to 1. Then we are iterating on the array, and we are iterating till the point array I is less than or equals to answer. And all we are doing is answer equals to answer plus array I, and towards the end we are returning answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.